Hey guys, welcome to the UH right triangles and sectors. No, I'm not talking to myself, I'm talking to my laptop here. We got a few kids here looking. Anyways, so here we go. Let's go over this, guys. It's not too bad. Hopefully, you find this UH quiz rewarding. Let's start. So it says in a right triangle ABC with right angle C, so that's the important part. AB is 12, BC is 4, find the length on the missing side. So here we go. So label that C, and it doesn't matter now which way you label A and B. You're out, Lanford?
Yeah.
All right, later.
Oh, wait, I'm still there.
Oh, okay. You're coming back. All right. So here we go. AB is 12, BC is 4, and they want the missing side. So you're just doing Pythagorean theorem, guys. If you want, I usually go right to the shortcut and just say that x is the square root of 12 squared minus 4 squared. Now, I'm going to advise against this unless, I don't want you to be a robot. The reason why I do that, guys, is because I already know Pythagorean theorem, and so do you guys, right? So I'm not insulting your intelligence. You guys should be doing x squared plus 4 squared equals 12 squared. And then what do? You're trying to solve for x, so move the 4 squared to the right. So you're going to have x squared equals 12 squared minus 4 squared, and then square root, and then you get x equals the square root of 12 squared minus 4 squared. So there it is. That's why I just go right into that, guys. So anyways, let's see what this is. 12 squared is 144, 4 squared is 16, and let's see, x equals 144 minus 16. Let's see, 144, 34, 24, 128. And I know that 128 is the same thing as 64 times 2. 64, the square root of 64 is 8. So 8 square root of 2. So there it is. Let's go to the next one, guys. They're about to make an announcement.
Lauren Bettis to the main lobby, please. Lauren Bettis to the main lobby.
All right, again, we got a right angle at C. So it doesn't matter now that you label that C. AC is 11, so this is 11. BC, oops, there's two C's in here. A, B, C, there we go. AC is 11, BC is 6. And it looks like I just want this missing side here. So let's see, BC 6, AC 11. So we're just doing Pythagorean theorem. Square root of 11 squared plus 6 squared will give me x. 11 squared is 121. 6 squared is 36. So 121, 31, 41, 51, 57. Square root of 157. And there it is, guys. Yay. Next one. In right triangle ABC, AB is 11. AB is 11. Find x. Well, it's a 45, 45, 90 triangle, guys. N square root of 2. So that 11 is the hypotenuse, so I typed that right there. So n square root of 2 equals 11. What you're looking for is one of these legs. This is n, this is n. You can also call it x, right? X. Doesn't matter. X squared root of 2 or n squared root of 2. So divide by square root of 2 both sides. And n equals 11 over square root of 2. Now, you're not going to find that answer like that, guys, because they rationalize it. So multiply by square root of 2 over square root of 2. So we get 11 square root of 2 over 2. So that answer is in there. It's right there. Let's go to the next one. Right triangle ABC is shown in the figure below. AC is 12 square root of 3. So AC is 12 square root of 3. Find x. Okay, again, guys, this is just a 45, 45, 90. And square root of 2. So you take that leg there, and you just multiply that dude by square root of 2. So you're going to go 12 square root of 3 times square root of 2, law of exponents. You have two radicands there. So square root of 3 times square root of 2 is square root of 6. So 12 square root of 6. There it is. The student got it right. Let's go to the next one. In the figure below, an altitude is drawn to the base of the equilateral triangle. So this is an equilateral triangle, so that means all sides are congruent. If AC is 10, so this is 10, that's 10, find AB. So all of that together, guys, is 10. Because notice that's 60 here. If you add those two angles, that's 60, that's 60. So in order for this AB to be 10, that means A equals B, which equals 5. So there it is. All right, let's go to the next one. In the figure below, the altitude is drawn to the base of the equilateral triangle. So this is called the altitude right here, guys, this distance. If AC is 3, the length of the altitude is, okay, so this is a 30, 60, 90 triangle. And you have n square root of 3, and 2n. So if you just focus on this one triangle here, that 2n is like 3, because it's like the hypotenuse of this one triangle here. So you can go 2n equals 3, divide by 2, divide by 2. So the short leg is 3 over 2. And then my long leg has to be, 3 over 2 square root of 3, which is what C is, because B is a short leg. So B is 3 over 2. And then my long leg C is 3 square root of 3 over 2. So let's look for that. So there it is. This person got it right as well. Let's keep going to the next one. If I'm going too fast, guys, please rewind or maybe push pause or maybe slow it down by 0.5. Anyways, let's keep going. Given triangle ABC shown below, find AC if AC is 12. So find X and Y. So AC is 12. It's a 30, 60, 90 triangle again, guys. 30, 60, 90, period, or degrees, degree, and n squared root of 3, 2n. So AC is 12. That's the long leg. We just said that, right? So 12, put it right there. So n squared root of 3 equals 12. We're looking for the short leg, and we're looking for the hypotenuse. So divide by square root of 3. So n equals 12 divided by square root of 3. Now again, they're not going to have it written that way, so we have to do something called rationalize. 12 square root of 3 over 3. 3 goes into 12 4 times, so 4 square root of 3. So that's my short leg, which is this dude, 4 square root of 3. Now to get my hypotenuse, you just double it. So doubling that, that's 8 square root of 3, and there it is. So look for 4 square root of 3 and 8 square root of 3. 4 square root of 3 and 8 square root of 3. All right, let's go to the next one. Right triangle ABC is shown below. If AB is 8 square root of 2, so 8 square root of 2. Find X and Y. Okay, again, guys, they're just testing to see if we know our properties. And n square root of 3, 2n. And that's the hypotenuse, so 8 square root of 2. So then that means my short leg has to be 4 square root of 2, because you just divided by 2. So my short leg is the x, so 4 square root of 2. And then my long leg is 4 square root of 2 times square root of 3, which is going to be 4 square root of 6. All I did was multiply 4 square root of 2 times square root of 3. That is 4 square root of 6. 2 times 3. All right, so this person got it right. There it is. Given triangle DF as shown below, DF is 26, EF is 24. Find sine D and tan F. Okay, so first I got to figure out DE there, guys. So to do that, we're just going to go square root of 26 squared minus 24 squared. So let's see what we get. I'm going to take my calculator here. Calculator. You can use a basic calculator for the, the simple things, guys. Nothing too crazy. So I can quit. 26 squared minus 24 squared. And enter. So square root of 100. So it looks like it is 10. So x is 10. All right, we got everything we need. They want sine of D. SOHCAHTOA. So since they want sine of D there, so there's my angle D. So sine of D is equal to opposite 24 over hypotenuse 26. So that reduces, let's see, 2 goes into 24 12 times, 2 goes into 26 13 times. So sine is 12 over 13. So maybe that one, maybe that one. And now let's look for tan F. So here's F. Remember that tan is opposite over adjacent. So tan of F is equal to opposite, which is 10 over 24. which reduces to 5 over 12. So it is this one. Yay! Let's go to the next one. Suppose that theta is an acute angle of a right triangle, and the tan theta is 4 square root of 2 over 5. Find sine and cosine. So the trick, guys, is to use this dude. So they're already telling you that tan is 4 square root of 2 over 5. This is all that is over 5. So I have a right triangle. Here's my right triangle. Doesn't have to be perfect. So tan is 4 square root of 2, and the adjacent is 5. You got to figure out the hypotenuse. So how do I do that? Square root of 4 square root of 2 squared plus 5 squared. So let's see what we get. 4 squared is 16. 16 times 2 is 32 plus 25. 32, 42, 52, 57. So square root of 57. That's what x is. It does not reduce. All right, so now let's find it. Sine. So I'm going to go, what happened there? Sorry, guys. Looks like I'm squeezing. Okay, anyways. So I'm just going to go sine. I'm just going to do SOHCAHTOA over here. And I'm going to write, what am I going to write? Sine, it says sine is opposite over hypotenuse. So sine of this angle is opposite, 4 square root of 2 over hypotenuse, square root of 57. Now you're going to have to rationalize it. So multiply by the square root of 57 over the square root of 57. So when I do that, you're going to get this answer. 4 square root, and then multiply, double the 57. 114 over 57. So, out. Oh, no, wait, I don't see it. I'm going to take a guess that there's something wrong with this. I'm going to say that it should have been like here. Let's see if cosine, if we get that answer there. Because I can see a comma there. So maybe the sine answer was right there, guys. So let's see what cosine is. Cosine is adjacent over hypotenuse. So I'm going to write cosine of that angle is adjacent 5 over hypotenuse. And again, I'm going to multiply by square root of 57 over square root of 57. So you get cosine theta equals 5 square root of 57 over 57. Is that what they give me? Nope.
Sir, has it ever been none of the above?
Yeah, it has. But it's not this one, though. I think this one has hiccups. So there's errors on this one. I'm pretty sure the answer was C. And I say that because I see a comma and I see the correct cosine. I see 5 over 57 square root of 57, which is what we got. 5 over 57 square root of 57. They just don't have the correct answer for sine. The correct answer for sine should be 4 over 57. I see 8. 4 over 57. But yeah, this one, they have the cosine, but that should be the one for sine. So I'm pretty sure that there's just a hiccup. So there it is. There's the hiccup. So it's probably C. So these are the correct answers, guys. Let's keep going. Suppose that theta is an acute angle of a right triangle and that secant theta is 5/2. Find sine theta and cotangent theta. Okay, so let's draw a right triangle. And here's a theta. So this is secant, which means cosine was 2/5. So put a 2 here, 5 there. I need to figure out this missing side. So to do that, you just go square root of 5 squared minus 2 squared. So 5 squared is 25, 2 squared is 4, so the square root of 21. So x is square root of 21. So now that I know that, I'm looking for sine. So sine of that angle is opposite over hypotenuse. So square root of 21 over 5. And now which one else do I want? Cotangent. So cotangent of that angle is, let's see, tan is opposite over adjacent, so adjacent over opposite. So 2 over square root of 21. So rationalize it. 2 square root of 21 over 21. So let's look for those answers. Sine Yeah, there's hiccups. Look at all the hiccups. So there's hiccups, guys. My apologies. I didn't notice that we're going to have this many hiccups. But, yeah, hopefully the future ones don't have these hiccups. Yeah, it looks like that's the only hiccups we have there. All right, so this one. Convert the following degree measure to radians. So we have 135 degrees. And now hopefully you guys remember. How do we convert degrees to radians, guys?
Oh, yeah. It's either pi over 180 or 180.
Pi over 180. So we're just going to go 135 over 180 in a calculator. I mean, I guess you don't have to if you recognize that that's a special angle. 135 over 180, and then convert that to a fraction, right? Math. Oh, you already see it, so you don't need a, but there it is. And then put a pi on the numerator. So 3 pi over 4. All right. And now we're going to do the same thing with this. 8 pi over 9 times 180 over pi. Pi's cancel out. So 8 ninths times 180. 8 ninths times 180. 160. So that's my answer. All right. Let's keep going. Ooh, now we got some fun stuff here. To find the length of an arc of a circle, think the arc length is simply a fraction of the circumference of the circle. If the central angle theta defining the arc is given in degrees, and the arc length can be found using the formula. And they didn't give you the formula. So the arc length, usually they use S. And they're telling you it's in degrees. So theta over 360 times 2 pi r, because 2 pi r is circumference. So there it is. Think of the theta over 360 as like a percentage. Use the formula above to find arc length S, where theta is 30 degrees and r is 90. So there's definitely some hiccups going on because they should have shown the formula, but it didn't show. That's fine. So here we go. 30 over 360 times 2 times pi times 9. So 30 over 360 times 18 pi. So 3 goes into 36. What's that? 12 times? 12, 24, 36. Yeah. So this is like saying 1/12 times 18 pi. So 18 pi over 12, and that reduces, let's see, 2 goes into 9 pi over 6, which reduces again into 3 pi over 2. So 3 pi over 2. I guess if you recognize it immediately, you can just go right to that. Next one is the central angle theta defining the arc is given in radius rather than degrees. Then the arc length can be found using the formula. And they don't have it in there, guys. So here it is. S equals theta over 2 pi times 2 pi r. Notice the 2 pi's cancel out. So this is why it's so sweet when we're doing it in radians. You can just go right into it. And remember, what is arc length? Arc length is like the exterior, right? Like kind of like circumference, but a percentage of it. Hold on, it's not letting me erase. Okay, sorry, not letting me erase. That's fine. So here we go. Arc length, pi over 6 times 9. So 9 pi over 6. So that's going to be 3 pi over 2. And really what we just did, guys, is we just calculated, what did we calculate? We just calculated the arc length for this. We just did this piece. That length there in blue is 3 pi over 2 yards. Cool. Alright, let's keep going. Find the perimeter of a sector of a circle with central angle 5 pi over 4. So what I really have is this. There's my circle, and the radius is 6 feet. So we got to calculate this arc length. So my total perimeter is 6 plus 6 plus S. That's not a 5, that's an S. S for arc length. I need to figure out the length of this guy in blue. And how you do that is, we just did it earlier, theta r. So, here's my answer. 12 plus 5 pi over 4 times 6. So what's that? 12 plus 30 pi over 4, which reduces to, let's see, 12 plus 15 pi over 2 feet. Yay. Right. Last one here, or I guess 3 more, and we're almost done. To find the area of a sector of a circle, think of a sector as simply a fraction of the circle. The center triangle theta defining the sector is given in degrees, and the area of the sector can be found using the formula. And they don't tell you anything. There should be a formula here, but they don't. Area of the sector is going to be defined by theta over 360 times pi r squared. And think of this theta over 360 as a percentage. So use the formula to find the area of the sector where theta is 270. So I'm going to write 270 over 360. No, you're good, guys. Times pi times 5 squared. So this is really like 3/4 there, right? 270 over 360. So notice if you put 270 over 360, guys, that you will get 3/4, 0.75. So I want you guys to start thinking like that. That's really a percentage. So 75% of your whole circle, which is pi r squared. So 3/4 times pi times 25. So 75 pi over 4 square centimeters. Okay, a sector of a circle has center triangle pi over 2. The area is 49 pi over 4 square feet. Find the radius. Okay. So here we go. This is my area. 49 pi over 4 equals, so we're going to do our little theta over 2 pi, right? So theta over 2 pi. So pi over 2 pi. So it was like, think of this like percentage. Like percentage times pi r squared. Pi r squared, and we're looking for r. Solve for r. All right, let's see. So this pi cancels out with this pi cancels out with that pi, keep, change, flip. 49 over 4 equals, looks like I'm going to get 1/4 r squared. So times 4 times 4, 49 equals r squared, because I just did times 4 times 4. And then square root, r equals 7. Yay. That was a cute smiley. I like that one. It's one of my best smileys. A car has wheels with 11-inch radius. If each wheel's rate of turn is 4 revolutions per second, find the angular speed in radians per second. This is pretty easy, guys. Just use dimensional analysis. 4 revolutions per second. In 1 revolution, there is 2 pi radians. So revolutions cancel out, and you get 8 pi radians per second, which is what they have here. So 8 pi. And then finally, a car has wheels with 8-inch radius. If each wheel's rate of turn is 5 revolutions per second, how fast is the car moving? So now we want linear velocity. So let's see, 5 revolutions per second. And in 1 revolution, you cover, remember, circumference of a circle is 2 pi r. And that's how much ground you cover, right, if it does 1 revolution? So 2 times pi times 8 inches. So let's see, 5 times 8 times 2 is 16 pi. And then 16 times 5, 16, 32, 64, 80. 80 pi inches per second. Alright guys, hopefully this video helped. Check it out, and I guess if you have any questions, I mean, I can't answer them right now because it's a video, but shoot me the questions and I'll answer them. Alright, later.